Hi everyone, I'm Andrew from Oasis Labs, and today we're going to talk about confidentiality on the Oasis Network.
I'm Warren, I'm an engineer here. All right, so confidentiality, that's that property of a system not to reveal information to the wrong users.
Cool.
Let's talk about a very confidential system we have here at Oasis Labs.
All right. So there go my notes.
We'll see if we can go without them. Okay, so if a system destroys all the data that you give it, then it's trivially very confidential.
Yeah. I'm not getting my notes back.
All right, so
In fact, no one is.
Right, no one can access that data anymore, and so that's confidentiality.
Yeah. At least in one form. Right.
And since we're not building a system exactly like that, we always discuss confidentiality along with the other side of it, availability, which is the property of a system to make sure the right users can access their data.
Got it.
All right. An example of a system with really good availability, are other blockchains where all the information about it is publicly available.
Yeah, that's that's one of the great properties of blockchains is that they have this immutable ledger. Obviously it can be tricky, right? Because sometimes you don't want things to be available to everyone.
Right. Right. And so we want to build a system that has both confidentiality and availability.
Got it. I see.
All right. And the way we achieve that with the Oasis network is encryption.
Okay.
Encryption scrambles data with a key, or for a key, so that it's hard to decrypt without that key. All right. And this is nice because it's easier to move keys around than it is to move the data that you would be encrypting. For one thing, the keys are small.
Yeah.
And another thing is that you can have a key shared one time and then later encrypt multiple messages for that key.
Yeah.
All right. And so if you make the encrypted data available widely, then you can achieve confidentiality by making sure that the wrong users don't have the key, and you can achieve availability by making sure that the right users do have the key.
Yeah, it's kind of like my apartment. Like, I've got a key to get in my apartment. It's obviously there. Anyone can walk up to it and look at it. But if you actually want to know what's inside, I have to give you the key to get in. And that's very easy because it's a small little key that I can hand around to people.
Yeah, you're not shipping your apartment around.
Yeah, exactly. Although that's a different video. No, I'm kidding. Okay, great. So, that makes sense to me. I think I understand what confidentiality is and how it kind of relates to this other important property of availability. But what does that actually look like, beyond just encryption, what does that actually look like on the Oasis network?
Yeah. So let's discuss that in terms of the actual security goal of the Oasis network.
Yeah.
And first, we're going to break down the system into some parts, and we're going to look at 3 of those parts. Those are the end user,
cool,
a compute node, and we'll also look at a storage node.
Got it. And this obviously isn't every part of the network, but they're important parts.
Right. Okay. Let's discuss this in terms of a sample contract.
Yeah, cool. So let's say we're going to vote on lunch today to see what we want to eat.
Sure. Yeah.
Yeah.
Okay. And so in a smart contract that does voting, you'll have a transaction input, which is what you're voting for.
Okay.
The contract itself is going to have an internal state with records of who's voted and for what.
So the previous round of votes or something like that. Yeah.
And then the transaction output, let's say, is the current winning option.
Yep.
And then as a result of this transaction, we're going to update that state and have a new state with this vote added.
Got it. So then now storage has kind of all the information about what's going on. Yeah.
Right.
Cool.
And so now let's look at who is sort of the right user for each of this data. Right. What we want to have is for the smart contract running on the compute node to be able to see what you're voting for.
Yep, it has to, right?
Right, and it should, it better be able to see its own state. whatever state comes out of it should it should be able to use in the next transaction.
Yeah, should be able to write.
And then the transaction output should be something that the voter should then be able to see.
Yeah, the winner.
All right. And so the way we do, so the answer here for a lot of this stuff in pink here is a bit unusual. It's not it's not something that any specific user should see or any machine, and certainly not the owner of this compute node.
Yeah.
As it should only be seen by this contract itself.
Yeah, like the contract is the one that has permission to actually tally the votes, keep record of the votes, and that kind of thing. We don't want, by design, because it's a blockchain system, we don't want to trust the node operator or a person necessarily. We want it to be kind of programmatically defined in the smart contract. But that's kind of tricky. I mean, I feel like on my computer, like if you have root access to the compute node, like you basically can see everything. So how do you prevent against that?
Yeah, the idea of being able to run something on a computer without the owner of that computer being able to see into it, it's not something a typical software system usually defends against.
Yeah.
The way we do this in Oasis is we run smart contracts in this thing called a secure enclave. All right, and then the secure enclave provides these two properties that make this overall possible. The first one is isolation.
Got it.
Which makes sure whatever's going on inside the secure enclave, the program and data, is isolated, is kept separate from whatever else the node owner is doing on that computer.
Got it. So if he's got some other, function running or application running, they're right, it's isolated from that.
And the other thing is remote attestation, which allows us to know exactly what program is running inside that enclave.
So we can be confident that it's the right smart contract, or the smart contract hasn't been augmented in some way maliciously.
Right.
Yeah.
And so, with the isolation in place, that makes it possible to have the smart contract have a key of its own, put into this secure enclave that we can encrypt these pieces of data for. And it's critical, how we get that key in there, which we'll discuss in a future video on key management, where we'll look at remote attestation in more detail. But so the incoming vote then will have the end user encrypt it for this contract specific key, and then we'll have the contract encrypt the state, the record of votes for its own key.
That goes into storage.
Yep. And then as it gets the previous iteration state from storage, it will have been encrypted that way from any previous transaction or when the contract was created.
Got it.
And then what we'll have is for the contract to encrypt the transaction result for the end user's key.
Got it. And that allows the end user to see, whatever the smart contract designates. In this instance, the winner, without actually knowing, who voted for what or any of the underlying information.
Yes.
Got it. That's very neat. Cool. Well, I think that's everything we had for today, but thanks everyone for watching, and check out some more of our videos, especially on key management, which will be coming up soon. Thanks. Bye.
Thanks.